Bismillahirrahmanirrahim. Dear student, Assalamu alaikum. I am Dr. Muhammad Majid, and today we will study the Gauss's law for n-point charges. So this topic, it is on page number 23. The same article of the Gauss's law, article number is 11.5, Gauss's law for n-point charges. Gauss's law for n-point charges. What we have studied so far, if you remember, we have studied the Gauss's law, and that was, let me repeat it, the net electric flux through any closed surface is equal to total charge divided by the permittivity. So if you are dealing with the free space, then it is epsilon naught. So Gauss's law, that's the relationship between the electric flux and the charge enclosed in any surface. For example, you have any surface and charge is there in that surface. So the Gauss's law relates the flux with the charge. So next we will study, we have proved this equation in our previous lecture, and that was for simply a single charge. When there is charge Q inside a sphere, let you have any closed surface. For example, you have any arbitrary closed surface, and that surface enclosed charges Q1, Q2, Q3, Q4 up to Qn and so on. You have any closed surface, and this surface contain n-point charges. So consider any arbitrary closed surface, a regular any surface that contain n-point charges, Q1, Q2 up to Qn. You have any closed surface, and this surface is enclosed by the n-point charges Q1 up to Qn. So how we will find out the total electric flux through all these point charges? Again, that's very simple. So let me write electric flux pi 1 due to charge Q1. Electric flux due to charge Q1 क्या होगा? Just use this relation. You know this Gauss's law. So यहाँ पे electric flux क्या होगा? Flux pi 1 equal to Q1 by epsilon naught. Clear? This is equation 1. Similarly, the electric flux due to charge Q2 is flux pi 2, that is equal to Q2 by epsilon naught. This is equation 2. Similarly, for flux due to charge 3, that is Q3 by epsilon naught. So if you net flux क्या होगा, total flux क्या होगा? That's very simple. That is pi 1, pi 2. Similarly, you have flux pi 3, that is equal to Q3 by epsilon naught, and so on up to n charges. You have flux pi n, that is equal to Qn by epsilon naught. Clear? So total flux क्या होगा? Total flux is very simple. Flux total, just add all these, that is flux pi 1, pi 2 up to pi n. You just add all these flux. So what we get? We get the final equation just by inserting all these values. Flux pi 1, it is q1 by epsilon naught. So that is q1 by epsilon naught. That is q2 by epsilon naught. And so on. Last one, that would be qn by epsilon naught. Clear? So this is constant 1 over epsilon naught. So just bring that outside. What we get, flux total is equal to 1 over epsilon naught times the total charge q1, q2 up to qn. Clear? 1 over epsilon naught times the total charge. q1, q2, q3, that these are the total charges enclosed the electricity. So this is the total charge enclosed by that surface, inside this surface. So I can write this equation is flux total equal to 1 over epsilon naught times the total charge by this surface. And let's, for example, the total charge, it is q, then flux equal to q by the epsilon naught. So that is the Gauss's law for the n point charges inside a closed surface, any arbitrary surface. So in our next class, we will find out the applications of the Gauss's law. So we will find out the electric field intensity, because this flux, this is equal to E dot A, that is related with the electric field intensity, and that is related with the q by epsilon naught. So we can find out the electric field intensity using the Gauss's law. There are some of the application of the Gauss's law which are very important from examination point of view, and we will do that in our next class. So remember, you can use Gauss's law in order to find out the electric field intensity, but you need some symmetry of charges. In majority of cases where there is not enough symmetry, then alone we cannot use the Gauss's law now to find out the electric field intensity. So if there are symmetric charge distribution, then simply we use the Gauss's law in order to find out the electric field intensity. So we will do some of the application of the Gauss's law in our next class. So we can use the Coulomb's law in order to find out the electric field intensity. As you know, electric field intensity, that was F divided by Q. That electric field intensity, you know, that was F divided by Q naught. Just like we did we have find out the electric field intensity for a point charge Q. So if you know this Coulomb force, you can find out the electric field intensity. So that's Coulomb's law की यही application है. You can find out the electric field intensity, and uses the Gauss's law again, you can find out the electric field intensity. So okay, see you tomorrow.